Kia ora koutou. This video is going to go through the last of the excellence questions on that mixed up worksheet that I gave you yesterday for working from home. So in this video, I'm just going to do this with algebra, which is actually kind of unsatisfying because this question has a ton of geometry in it. I'm going to try and do a series of videos on this pattern type of locus problem, but I need to just take a little bit more time to set it up. So this video is going to get you through to the answer that gave you an excellence tick in the level 3 exam back in 2015, and it's going to go a little step further with reforming that equation into the equation of a shape. Okay, so all we have to do to get a tick here is we just have to find the Cartesian equation of the locus described by this. Cartesian equation just means I need to find an equation that's got stuff with x squared, x's, and y's, and y squareds. Right, so just an equation, blah, 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 equals something. We don't have to put that into the form of a parabola or a circle or anything like that. But I want to show you how to do that, which is basically completing the square on both the x bits and the y bits. But the last part, the geometry part, I'll save for later on. So let's look at what this complex number is. So let z is equal to x plus iy. So z minus 2 over z plus 5 is equal to x plus iy minus 2 over x plus iy plus 5. I'm going to group the real bits and the imaginary bits, and then I'm going to multiply by the conjugate. So we'll multiply through by x plus 5 minus iy, like that. And if we clean that up, let's do the denominator first. We get x plus 5 squared minus I squared y squared, because I've got a difference of two squares. So that gives me plus y squared. And in the numerator, we get x minus 2 times x plus 5 minus y squared I squared, so that's plus y squared, so that's those ones done and those ones done. And now with the complex bits we get plus I times y times x plus 5 minus y times x minus 2, not plus 2, minus 2. And you've got to go really carefully with this, or it is all not going to work out beautifully, because a whole bunch of stuff here is going to simplify. So the real bit doesn't have anything much to do to it, so just leave that like that. But when we start looking at the imaginary bit here, you can see some simplification. So we get xy plus 5y minus xy plus 2y. And that's over this denominator, which it turns out is not going to matter very much. And that's often the pattern with locus problems. So cleaning this up, we've got x minus 2 times x plus 5 plus y squared plus 7yi over this. And you can see that that denominator is always going to be positive. Now what we need to do with that is we need to find when is the arg of this number equal to pi on 4. So we've just found out that this number is this thing here. So for the arg of something to be pi on 4, we want the real part and the imaginary part to be equal. That means that we need, and that picture is actually not right because we also have to be in the first quadrant. So a better picture is to say that it has to be in the first quadrant and it can't be the origin. So that means that 7y must be positive, and then this real bit here is going to have to be positive too. Now that condition is not imposed in the level 3 calc papers, and they're often fairly loose with those restrictions. When I do the next set of videos and we do it geometrically, it's much easier to get those restrictions all figured out nicely. Right, but for now, we're not going to worry too much about the part that makes it in the first quadrant. We don't want the bit down here. So that means that the real part and the imaginary part must be equal. So the real part of z minus 2 over z plus 5 has to equal the imaginary part. And we can ignore the denominator because it's equal. So we've got x minus 2 times x plus 5 plus y squared over blah, blah is equal to 7y over blah, blah. And I'm just going to call that d for denominator. All right, so d is equal to x plus 5 squared. So we can times both sides through by the denominator. And now we've nearly finished for the purposes of a level 3 excellence tick. So we've got this. Expanding gives me x squared plus 3x minus 10 plus y squared minus 7y is equal to 0. Okay, so that's the tick for that. But I don't know how you're feeling about that, but that tells me really not much about what kind of shape is going to give me that result. And it gives me no intuition at all for why. That's why we're doing the harder videos on this in the next week or two. What I'm going to do now is I'm going to complete the square on this and on this. And we'll see that this is the equation of a circle, and we can easily see the radius and we can see the center. X plus 3 over 2 squared, so this is completing the square on this, minus 9 over 4, plus y minus 7 over 2 squared, completing the square on this, minus 49 over 4, minus 10 is equal to 0. I think that's correct. I'm just checking. Yep, so this bit here, just check again, check that we're working backwards. I'm halving that 3, and that's giving me 3 on 2, and I'm halving that 7 there. It gives me a circle with a centre at negative 3 on 2 and 7 over 2. And that equals 40 over 4 plus 49 over 4 plus 9 over 4, which is equal to 49 and 48, 998 over 4. We can simplify that, can't we? That can divide by 2, so that gives me 49 over 2. So you can see that we've reworked that equation into a circle, and it's got a radius of 7 on root 2 and a centre of negative 3 over 2 and 7 over 2. So we're going to come back to this question and look at why that's where the centre ends up being and why the radius ends up being 7 over 2. But that's all for tonight, and that gets us right through that worksheet. So just let me know if you've got any questions or worries about it still, and next week we're moving on to trig.